The midpoint of a line segment divides the line segment into a ratio of 1:1. When the midpoint between 2 points is required, it can be found by substituting the coordinates directly into the midpoint formula. We start by labeling the coordinates of A as x1, y1 and B as x2, y2. These values are then substituted into the formula as labelled. Another method of finding the midpoint of a line segment is to use a translation. A translation is a geometric transformation that moves a point by a given amount in a given direction. The translation of A to B is written in this format. It is known that the midpoint divides a line segment into 2 equal lengths. Therefore, the translation can be halved to yield the midpoint. We will practice both of these methods later. The midpoint is known to divide a line segment into 2 equal parts. On a number line, the middle number of 2 numbers is the mean or average of the numbers. The mean is found by adding the 2 numbers and then dividing by 2. Applying this to our line segment, the midpoint is the mean of the x and y coordinates. In this practice question, we must find the midpoint of the line segment AB, where the coordinates of A is 2, 3, and the coordinate of B is 4, 7. As we have the coordinates of the 2 points, we can use the midpoint formula. We start by labelling the coordinates x1, y1 and x2, y2. Next, we substitute the values into the formula as labelled. We can now tidy up each side of the comma, giving us a midpoint of 3, 5. In this question, we need to find the midpoint of the line segment AB, where A is 2, 3 and B is 4, 7. Here we will practice using translations. We start by determining the translation of point A to point B. The operation of this translation is +2 + 4. As we are looking for the midpoint, we will halve this translation. Therefore, the operation of our new translation is +1 + 2. Performing this translation on the point A moves it to the point 3, 5, which is our midpoint of the line segment AB. In this question, we are given the midpoint of the line segment AB as the point 3, 5. But we need to find the coordinates of B, an endpoint of the line segment. In this type of question, we will use the converse of the midpoint formula. We start by substituting everything into the formula as normal and using the letters x and y for the unknown coordinates of B. The midpoint formula contains a comma, which allows us to break and separate the x values from the y values. We can now solve each part for the variables x and y. Simplifying gives us an x value of 4 and a y value of 7. Therefore, the coordinates of B is 4, 7. We have completed the theory section of the module. We can now practice with past exam questions. When each question appears, please pause the video and attempt the question. Again, don't be afraid of making mistakes. It is only through attempting questions will you become proficient. When ready, press play again and you will see the question fully worked and explained. In this question, we are given 3 coordinates, P, Q and R. and we are told that they are the vertices of a triangle. We are told that V is the midpoint of the line segment PR. We are asked to find the coordinates of V. As we are given the coordinates of the points P and R, we can use the midpoint formula. We start by labelling the points x1, y1 and x2, y2, and we can substitute them directly into the formula. Simplifying gives us a midpoint V as 9, 7. Here we are given the coordinates of 3 points A, B and C, which are the vertices of a triangle. We are asked to find the coordinates of D, the midpoint of the line segment AB. As we are given the coordinates of A and B, we could use the midpoint formula, but here we will practice the translation method. We start by determining the operation of the translation of A to B. So we work out what happened to the x-coordinate and then the y-coordinate. The operation is -6, -4. We must now halve this operation, giving us -3, -2. Applying this operation onto the point A gives us a midpoint coordinate of 1, 4. So D is the point 1, 4.